on which layer OSPF works? And readily the answer would be L3 usually, and that would make the interviewer not happy. A quick answer is when you do the lab, the quick answer is when you do the lab, you go and open up different layers. If it's on layer 3, you should find it on layer 3. And the quick answer is you would not find it on layer 3. So, but there's a huge discussion under this. And if you go over the internet, you would find in different Cisco forums, a lot of opinion in there. But I would just share with you what I understand on that issue. But you have to understand a few things in order to really sort of be crystal clear on the issue. First thing we need to go back and look at is role of IP layer. IP layer, or the layer which deals with IP addresses. So what it does, if I am a router, I would receive a packet. It would have destination address. At runtime, at real time, when packet comes to me, I buffer it if I have to. Then I look at the destination address, and if I'm receiving at this port, right, F01, and I have 2 ports shown here, let's say 00, F11. So I have to decide that I would forward this packet or not. If I decide to forward this packet based on this set destination address, I would forward it to one of the hops, towards one of the hops. So I would send out in the direction of any of these 2 interfaces which I have in this example. This is the role of IP address layer L3. Okay, what is not my role here? So these are not my roles, so I'm putting across. For example, how a routing protocol works. How I got this forwarding table. Which I consulted, and based on that, I forwarded this way or that way. And how the updates are happening. I have no concern with that. If I am on IP address layer, where I deal with IP addresses, my only job is what I explained here. At runtime, I will look at destination address. I will consult my forwarding table and see where I need to forward it. This interface, that interface, that interface, and that is what my job is. How I get all those things, not my job. So it means, what are the various sources I can get this information? How I can get the forwarding info? Okay, so here I would, let me, routing protocols. So routing protocols, or even no protocol. Oops, oh, my pen is getting messy. Contract protocol. Or even no routing protocol. For example, I may have different ways to do all these red things. Number one, I'm a network engineer. I am doing static routing. For a small network. Network engineer, I'm doing static routing for a small network. So the forwarding decision would be based on me. So it means this human is sort of creating routing info and telling how to forward a packet. In other words, this is a human which is making that forwarding table. This is human that is making forwarding table. So the same job is done by RIP or OSPF in dynamic routing or other players, EIGRP or BGP or ISIS. If I try to place any of these protocols on a certain layer, what's about this guy? I should also try to place him on some layer because they are doing the same thing. Whatever that network engineer is doing for that small network through static routing, the same thing dynamically is being done all other routing protocols. So they are all alternate arrangements with the same final objective. Someone does it better than the other. So from there, if you feel where I'm trying to bring you, I want to give you an argument that a routing protocol, what it does, it sort of creates and communicates the control information. So any routing mechanisms, routing protocol. So they do the global interaction. And collect information to help a router make decision based on IP addresses, where to forward. So information so that routers can do their job. What job? I already explained to you what the job is. No, you look at where do they run, right? For example, there's a big example we already were talking about. We said ISIS runs over L2. It's doing the same job which OSPF is doing. And many service providers, they are convinced that it does job better than OSPF. You agree with me or not? So all of these 6 alternatives which we wrote over there, all these 6 methods, they populate routing table. they populate routing table. Once routing table is populated, we use that routing table to make forwarding table. So once I have this forwarding table, then I look at the addresses. That's what layer 3 does, right? And I make the decision where I should send out of my local interfaces, where I should send it. So that means that data structure, which I need to make such operations and forwarding decisions or blocking decisions, they are there relevant to this layer. If I try to place all these protocols on certain layer, so some of the commentators argue then you have to place that network engineer on some layer as well. So you should look at what is the role of these protocols and what is the role of the layer which is dealing with IP addresses. So that would bring us to a point, what we could do, we could then, okay, if that's the case, why not we make a position for what position we should take for routing protocol. So from my argument, it looks like I don't want to place them on this layer system, then where they should go. So let's talk about the position of routing protocol. Do you guys have your result out?
Yes, sir.
So by looking at this, so on one side you have, let's say, layer 3 operation. I'm writing again. Layer 3 operation. Layer 3 operation is what I receive packet. Then I decide which interface I send it out, if I have to. Send out from. So that is what I do. This is what layer 3 operation is. So where I get the support for this operation. So what is my key thing to have it here? I need to have forwarding table. Now, I don't care if that forwarding table is statically made by a network engineer or is produced by a dynamic protocol, those 5 protocols we mentioned on the top. I don't care. This is my job. This is what L3's job is. Okay, that's what I make the decisions. So who helps me to get this forwarding table? So of course, routing protocols help me to do that. So it means the support which I need to do this kind of operation comes from routing protocol. Which comes from routing protocol. So if the routing protocols are not there, I would not be able to do these forwarding decisions. That means, should I place them on this layer? No. No, I should not place them on L3. And I should not confuse myself and others by saying they are on a certain layer, because they are support. So if I say they provide support, do you feel they belong to this layer system?
No, sir.
No, they don't belong to this layer system. So where we can find the evidence? So let me give you evidence. So for one evidence, I will say, if you look at ITU document, International Telecom Union documentation, and you see how they document, and you would learn that they document routing protocols, separate from layers. Separate from layers. Layers mean OSI model. So they have a separate heading for that, and they call, I had made a note of that heading. They call moving the bits frame packets. So under this heading, they put the routing protocols. So they move the bits frames packets, and they provide the basis of the support based on which L3 makes decisions. This is one evidence. Let me give you another evidence. I made a note, I guess. Let me see. I had a couple of pictures put on a file here. So there's an RFC. RFC's name is 1812. And I'm copying two pictures from the index of that RFC. And then you see where they are there. Okay, so this is a picture. So in this RFC, this is the index of that RFC. You see, it is talking about application layer things, and you see where the protocols are. Let me give you another screenshot or part of this index. So this is evidence number 2. So this is the index of this RFC. And you see where they are listing these protocols.
On application layer?
On application layer. But this
Yes.
is also not standard in the industry. They say, oh, they don't do, I will share that argument with you as well. But for the time being, so in saying that where the standards think they are, I am giving you example of 2 standards. I'm giving you RFC 1812. You can go check yourself. ITUT, I pulled it up and I'm copying here, and ITUT. So they put it under these headings. So that makes it clear. So in the standardization people, they don't think that, you know, they are part of layered system. So they support the system, and I explained to you how they support it.
But sir, with reference to OSI model, it belongs to layer 3, right?
No, that's what I'm saying. It does not. They don't mean these are the people who make standard. They say no.
Okay.
I'm giving you the evidence, right? But
Yeah.
the story is not yet over, so I have to bring in the other perspective as well, right? So let me go down a bit. Okay. So here, yeah. So, but you see, there some people, they say, so there are many people who consider them sort of application layer level, but then people give an argument somewhere. I was having an argument noted down somewhere when I was working for that. Maybe it will come down to my mind and I will share with you. So this is one thing. Another thing you should keep in mind, let me bring that layered thing into picture as well. Let me talk a little bit about layers. Okay, so layering. Okay, let me take you back to your physical and data link course. And there you were talking about peer-to-peer level. And you say, if I have a layer n, there will be n+1 layer. So n+1 will provide the service to n+1. And that means the other way to say is n+1 depends on the service of or service provided by layer n, right? You have studied that in physical and data link. So the argument here is there are two characteristics. There is a characteristic of layer 1, layer n. Layer n and a characteristic of so as a matter of fact, whenever you talk about peer-to-peer protocols, or that means you are talking about the layered system. In layered system, a layer is known by the service it provides, not by the service it takes. Than the service it avails. And this is a pretty important argument, and sometimes we put it on the side. So, I mean, if I'm to be proud for being a layer, I should not be proud of what I take service from. I should be taking pride in what I provide. If layer n, the layer below, then n+1 provides a service, that is sort of for me say, hey, I provide a service to n+1. n+1 cannot say that proudly, hey, I take the service from n. So the credentials of a layer is based on more than the service it provides than services takes, not a service they depend upon. So this is something which you keep in mind. Then people run into the problem of the two standards in the same context. OSI layers and TCP/IP layer. So I don't want to get into this discussion, but there has been a discussion because they say they try to force. There's a forced mapping of TCP/IP into OSI layers. So they say there's a big discussion you would find in the literature to say, I mean, they came up with TCP/IP altogether, a different layering system, and then they tried to compare that with the classical OSI model and they say it's not possible. You can take them without. So if an interviewer first asks me, oh, which layer it works on, I should ask that interviewer, sir, are you talking about OSIE or are you talking about TCP/IP? So that would tell him, okay, I mean, I know things. So they say a big confusion has come from this, that industry has tried to superimpose TCP/IP on OSI layer, and such questions become more confusing then. So TCP/IP not designed as per OSI, it's independent something. They never thought of OSI model. And once it became into being, then people tried to sort of fit it into the OSI model. So some confusion arose from there too. If someone asks me, I should ask a counter question. Sir, are you asking me to give my comment on as per TCP/IP or as per OSI? Because my answer might be different. Okay, so that's another concept we should keep in mind.
So here, if we look into the how protocol it works, so if we talk about OSPF, it's the transport method for OSPF. It uses IP protocol, not TCP protocol. As
yeah, I'm coming to a couple of more points, so maybe okay. These things will be covered. And you hold on to your question if it's still there, so you can ask. So as we have hinted from here, as I gave you a couple of examples, that routing protocols are listed separately from the layering functions. So let's consolidate that. So I've given you two evidences here. So let's consolidate that. Let's consolidate that by introducing a section, let's say, control information beyond layering. And I will cover the examples which you were trying to bring in, right? Control information beyond layering. So we see in layers, we make decisions, right? So I draw a couple of layers for you. For example, on L3, I already explained to you how the decision is made. Similarly, on L2, based on MAC, we make decisions. And for making those decisions, we get support from the protocols related to those layers. And we made it clear that the role of these layers is to make those decisions. So if I'm on layer 2, if I take you to physical and data link, so my job is to see if I have to drop that packet, if I have to forward it, if I have to broadcast it, what I would do. That's what I do based on MAC addresses. How I build that, I got that all information from bridging protocol or STP, or kind of all those things which play a role in there. So there is a separate entity which brings in support information for you to act. Right? So let me give you a few examples. Right? So so here I already gave like two scenarios, a MAC or layer 3 scenario. Let me give you examples. For example, take an example 1. Example 1, for example, because you guys have BGP introduced, let's say BGP. Okay. BGP delivers information, control information, right? So that my packets could move, right, for the internet network. And BGP runs on what? in order for BGP to run, what do you need? Not many people may know, people who have experience. So because we have to yet cover BGP, but it's coming like prematurely here.
In terms of AS number and
No, BGP on a protocol layer needs to be run over which protocol?
it
First,
use protocol as a IP and transport as a TCP port
so
170.
in order to have BGP work, first I need to set up a TCP connection. So I will talk about it as we move. If I want to set up a BGP, in order BGP to work, first I need to set up a TCP connection.
Yes.
So I could say BGP runs over a pre-established TCP connection over.
Yeah, because it do the handshake. Yes.
Yeah. TCP connection. Right. So is BGP an application layer protocol? Not really. Why? Because it does not deliver or provide application layer services. So this is the argument to this argument. When people see it, all those protocols, I show you BGP listed in application, they say, oh, they don't provide any application layer services, right? So, I mean, that's kind of the counter argument. And people who put them in, they say, you know, they have nothing to do with this layer system, but they in the operation, but they provide information support for that. So if they don't provide, they will not work. So they say, because they provide, they say, oh, it's an application. So this is an example where, for example, BGP is running over TCP. So you keep in mind, let me give you another example. What I want to tell you is layering is just a loose concept. I mean, it is taught to us, they are very tight, you know, layer, but they are not that tight. And sometimes their dependency looks odd as, you know, see, now BGP, what BGP supports? L3 operation, and where it is running over L4, right? So you are running over L4, but you are providing L3 support, because eventually we provide support here. Let me give you another example. You are expert in TCP better than me. So in TCP, do you know what is TCP MSS? Maximum segment size, perhaps?
Yes.
Okay. And similarly, you see on MAC level or layer 2, you have MTU.
Yes.
You have studied MTU. Okay. So you see, you tell me when I'm talking about the maximum payload size of L4, when I talk about MSS of L4, because I'm talking about TCP, okay, which is L4. MSS depends on MTU or not?
Depend on path.
It depends. Okay. So MTU is layer 2. How come a layer 2 information has gone to layer 4 if they were strictly sort of, you know, there and they're apart from each other?
That is path MTU. It goes with the TCP with the 3-way handshake.
Yeah. So with this example and this example, I want to highlight a point that when you are talking about the control information to support an operation on a certain line, this strictness between two layers or among multiple layers is not really observed. So size of MTU from 2 layers down is learned for making a decision for MSS on layer 4. And you see layer 3 information going on layer 4 and then, you know, sort of supporting layer 3. So for the purpose of the operations, there's a lot of cross-layer communication which is going on, which is against the strictness of the layer. So when we say in peer-to-peer, oh, N only talks to N. So that's another point you should keep in mind. Now, finally, this is not relevant to that answer, but this is relevant to highlight how much belief we should have in that layered system. Okay, so let me show you two Wiresharks. One you might have seen. So I picked up random from internet. I have not run anything to create them, but you might have seen it. So, okay. So if you look at it, you look at the layer 3, look at this row. Okay. So this is showing you, when you look at it, what you could say, what I have opened up here. TCP. Yeah. So you look at the role of IP. Look at here, what is my role? I'm dealing with source and destination, and I want to go for the destination where I should go. So if I copy another diagram, I have it here. My mouse, I lost my mouse. Okay. Yeah, the one node dies when you put a big diagram. You see the role of Internet protocol or IP layer or L3 layer. Now, what I am here, I'm opening up an OSPF packet. So if this is L3, of course, this is L4, where the OSPF is. You see, is OSPF running on L3? Why it is running on L4? Because it is providing transport mechanism. It is providing transport mechanism, right? Which is the role of L4. If for example, if I don't have an example, I have a short for RIP, for example. Put a picture here. So that you might have done in your first course, right? You see here, so here I'm telling you RIP, right? So you see same role of L3. Now you have UDP, and then you have RIP. So that's where the comment comes that RIP works on UDP or TCP. Why we say that? Because I would see a port number there. So by RIP being working on UDP, I still support L3 operation. If I put ISIS in here, so I would be running on top of layer 2, and I will be supporting the operation on layer 3. So you see the operation of layer 3 does not change. Operation of layer 3 is what, no matter you are telling me through RIP or OSPF or ISIS, my job is to look at the destination and see which interface I have to send out, looking at my forwarding table. Where I got my forwarding table from a routing table. Who built that routing table? Some protocol. So which layer OSPF work? It has two roles. It supports the operation of L3 by exchanging routing information with all those different things we discussed. And then it also works at the transport layer as well, wherever OSPF is used. In comparison to this IP needs UDP or TCP as a transport protocol. And they work on a port number, so that's an evidence for that, and you might have seen that. So when you go to your OSPF lab, please, when you do your Wireshark, open up these layers and try to conceive for yourself so that you have a solid position. And if someone asks, you can come up with acceptable arguments in order to answer the question on which layer OSPF work. And at least you know what is the connection between the layers operations and the protocols, and where protocols are listed. Why people list them under applications? Because what application help us? My email application helped me to sort of open an email or whatever, right? So similarly, I have to do routing decision, so someone helps me. So that's the kind which calls them application. As such, they are not application from that point of view, because they don't position on really application layer. Then some people say it's not application. When they say they are more looking at OSI model, but when you go look at TCP IP model, you don't have much layers after the transport layer. So what is on top of transport layer? So anything which facilitates L3 or transport layer, what you will call that. So from that perspective, they say, hey, if you don't take help of those application type things, you will not be able to do your decisions and function. So that's kind of the discussion in that perspective.